Hi, in this video we're going to look at the kind of units and numbers that I will be recording whenever my calculation involves measured quantities. A measured number is something that I measure with either a sophisticated device or a simple thing like a ruler. And whenever I do a measurement, I need to add the relevant unit. For instance, not just 5, but 5 centimeters, inches, meters, gram, kilogram, milliliter, ounces, pounds, dollars, cents, Swiss francs, and whatever. These are the kind of units that we're talking about. I treat units as if they were an x. For instance, 3x plus 4x is 7x. Whenever I add or subtract with an x, I keep the x as is. That's what I do when I have units. Therefore, 3 inches plus 4 inches, and the answer is 7 inches. I kept the inches. I will do the same thing if I subtract. When I multiply, it's something different. X multiplied by itself is x squared. So 3 feet times 2 feet is not just 6 feet, it's 6 square feet. When I divide, x over x is 1. So my answer, 6x over 2x, is 3. The x got cancelled. Well, milliliter over milliliter is also 1. So my answer becomes 3. The milliliter got cancelled. Weakest link idea is that when you have thousands of links in a chain, the chain is as strong as its weakest link. So when I'm doing measurements, my weakest measurement is either the one that has the fewest significant figures or the one that has the fewest decimal places. It depends on the case. The significant figure rule is for multiplication and division. I will be counting the number of significant figures in each of those quantities that I need to multiply and divide, and I will give an answer that has as many significant figures as in the weakest measurement. Example. Here I multiply 3.4 centimeter by 2.111 centimeter. My answer will have the unit centimeter squared, because I treat the centimeter like an x. Now, what about significant figures? Let me grab a pen. Here we go. 2 significant figures here and 4 significant figures there. So this is my weakest measurement, only 2 significant figures. I use the significant figure rule because I'm multiplying. So even though my calculator says this, I ignore it and I round it to 2 significant figures. My answer, 7.2, 2 significant figures, centimeters squared. The decimal place rule I will be using for whenever I add or subtract measured numbers. I will be looking for the measurement that has the fewest decimal places, and my answer will have as many decimal places as the measurement that has fewest decimal places. Here I have 1 decimal place, 3 decimal places. So even though my calculator is telling me all of these digits, my answer, I want to round it to 1 decimal place, which means 5.5 centimeters. I kept the centimeter as is because this was addition, and I used 1 decimal place, the weakest link. What do I do when I have a bunch of operations rather than just one? So I just need to follow the correct order of operations, so-called PEMDAS. I need to break the calculations to step-by-step job. Whenever I see that I need to multiply or divide, I will use the sig-fig rule. Whenever I have to add or subtract, I will use the decimal place rule. For instance, I'm going to give you like 3 different examples. In the first example, I'm trying to figure out the density of a fish by the water displacement method. This entails first finding the mass of the fish by placing it on a mass scale. then dunking the fish into a graduated cylinder. Before I dunked, the volume was 31.9 milliliter. After dunking the fish, the volume rose to 37.9 milliliter. This allows me to find the volume of the fish by subtraction. Density is defined as mass over volume, so the density of the fish is equal to the mass of the fish, numerator, divided by the volume of the fish. Here is the subtraction job. Doing a subtraction first according to the order of operation, and this will give me, and I will be counting decimal places. So I need one decimal place in my answer. This gives me 6.0 milliliters. Milliliters, I kept the unit because this was subtraction. Now I see that I need to do a division job. For division job, I forget about decimal places. I only am interested now in significant figures. Here 3, here 2. My weakest link has 2 significant figures. So whatever my calculator says, I'm going to come up with 2 significant figures only, 1.0. I rounded this number up, and my units are gram over milliliter because the gram and the milliliter did not get cancelled. My next example is about calculating percent error following this particular formula. So what if I measured a sample of gold? I found that its density was 19.9, but I'm aware that the true value is 19.3. I'm doing my plug and chug, and I see that I have to do several jobs. First, subtraction, then place it in the absolute value, and then division. Subtraction only, I'm thinking decimal places. I want, my weakest link has 1 decimal place, so I want to call it -6 gram per milliliter. But then I take the absolute value of it and I get positive 0.6 gram per milliliter for just the numerator. Then it's time for me to forget about decimal places. I am now going to count sig figs. Here I have only 1 sig fig. Here I have 3 significant figures, so the 0.6 is my weakest link, and I have only 1 significant figure. What about the 100? Well, the 100 is a definition. We know that 0.01 of a pizza is equal to 1% of the pizza, because we just take the 0.01, multiply it by 100, we get 1%. So the 100 is not a measurement, it's a definition, which means not to worry about significant figures here, only here and here. So here I have 1 significant figure, my weakest link. My answer should not be all of these numbers, but simply 3%. My last example has to do with calculating slope. Slope is rise over run. So I have a graph. I chose 2 points and I labeled them P sub 1. Here are the coordinates of P sub 1. And P sub 2, here are the coordinates of P sub 2. And my job boils down to subtracting 1 y coordinate from the other, subtracting 1 x coordinate from the other, and then dividing the result. So for subtraction, I'm thinking decimal places, and my answer is 1 decimal place, and I kept the unit meters. Subtraction along the denominator, I'm doing the same thing, 1 decimal place, and I keep the unit second. So now I'm moving to dividing, and when I'm dividing, I'm forgetting about decimal places. I'm all about sig figs. Here too, my weakest link has 2 significant figures, so I'm giving 2 significant figures, and my meters and second did not cancel, and I therefore state them. Okay, now if you need more practice, why don't you go to lecture resource B in your lab manual and try it from scratch and then compare with my key posted on Canvas. Thanks for watching.